Let's get some more practice with the RS system. So we'll start with this compound right here. We already know from earlier videos that this carbon is a chiral center. So let me go ahead and redraw everything because it's going to help us assign a configuration. So that's that carbon. We have a methyl group coming out at us. So I'm going to draw in the carbon with the hydrogens here. We have a hydrogen going away from us. And going to the right around the ring, we hit a CH2, so I'm drawing in a carbon with two hydrogens here. And then we hit CH, so this carbon bonded to a hydrogen, that's this carbon on the ring. Notice that this carbon that I just marked is double bonded to this carbon. And for the purposes of R and S system, we're going to pretend like this carbon is bonded to two different carbons, even though it's really one. So that's how to handle a double bond. Going this way around the ring, we hit a CH2, so let me draw that in. So here's our CH2, and then we hit another CH2 right here, so a CH2, and then this carbon is bonded to this carbon, so I'm just going to draw a line in there like that. All right, let's think about priority. So this is our chiral center. Let's look at the four groups attached to the chiral center. So this is step one. Prioritize the four groups using atomic number. So what's directly attached to this carbon? There's a hydrogen, there's a carbon, there's a carbon, and there's a carbon. So carbon beats hydrogen in terms of atomic number. So hydrogen is the lowest priority group. So we assign that a group number 4. All right, now we have a tie. We have three carbons. So we need to see what those carbons are directly bonded to. Let's start with this top carbon here. This carbon is bonded to hydrogen, hydrogen, hydrogen. So let me write that down. So hydrogen, hydrogen, hydrogen. Let's move to this carbon on the right. This one's bonded to carbon, hydrogen, hydrogen. So carbon, hydrogen, hydrogen. We're thinking about the atoms directly bonded to it, and we're going in decreasing atomic number, which is why I put the carbon first. Now let's look at this carbon. So this carbon is bonded to a carbon, a hydrogen, and a hydrogen. So CHH. All right, let's compare now. Well, first point of difference. We look at the first atom here. This is a hydrogen, and this is a carbon. So carbon beats hydrogen. And then over here we have a carbon. So this one doesn't win. This one must be third in terms of priority. So I put a 3 here for this methyl group. And now we continue on. We have hydrogen versus hydrogen, so that's a tie. Another hydrogen, so we have another tie. So we need to go to the next atom to break this tie. So we go to our next carbon, so this one right here. What atoms is this carbon directly bonded to? Well, it's bonded to carbon, carbon, hydrogen, so carbon, carbon, hydrogen. This carbon is directly bonded to carbon, hydrogen, hydrogen. So carbon, hydrogen, hydrogen. We look for the first point of difference. This is a carbon versus a carbon. This is a carbon versus a hydrogen. So the carbon wins. And that means that this way around the ring, this is the higher priority path around the ring. So this gets a number 1. And then this path around the ring going this way gets a number 2. So now we've assigned priority to our 4 groups. So now we're ready for step 2. Orient the group so the lowest priority group is projecting away from us in space. So let's go back to our original dot structure here. We said that this way around the ring was the highest priority. So this got a number 1. Next, going this way around the ring was second highest priority, so a number 2. Our methyl group was a number 3, and our hydrogen was a number 4. Our lowest priority group is going away from us. Our hydrogen is on a dash, so that's going away from us in space. So now we have finally on to step 3, and let me change colors again because it's getting a little busy here. So step 3, determine if the sequence 1, 2, 3 is clockwise or counterclockwise. So if I look 1, 2, 3 and I go around a circle, here's 1, here's 2, and here's 3. So going around 1, 2, 3 in a circle is this way, right? That is clockwise, right? You can see that's clockwise right here. And so clockwise is R. So the configuration of this chiral center is R. Now let's look at this compound. So we have only one chiral center to worry about. It's this one right here. Let's think about the atoms that are directly bonded to our chiral center. Well, there's a bromine directly bonded to it, a chlorine, and over here would be a carbon, and then we have another carbon. So we prioritize our groups in terms of atomic number. Bromine has the highest atomic number out of those atoms, so we give bromine a number 1. Next would be chlorine with atomic number of 17, so that's number 2. And then we have a tie for our carbons, so we need to see what is directly bonded to those carbons. So for the carbon on the right here, this carbon is directly bonded to a carbon here, and then of course a hydrogen. So we write that in as carbon, carbon, hydrogen. And then for the carbon on the left, so this carbon, that carbon's bonded to a carbon and 2 hydrogens. So we write in carbon, hydrogen, hydrogen. We look for the first point of difference, so we have carbon versus carbon, so that's a tie. So we keep going, and we get carbon versus hydrogen. So the carbon wins, and this group gets the higher priority. So this isopropyl group is a higher priority than this ethyl group. So that means the isopropyl group is going to get a number 3, so this is 3, and the ethyl group is the lowest priority. It gets a number 4. Now that we've assigned priority to our groups, we need to orient the molecule so the lowest priority group is pointing away from us, and the lowest priority group is group number 4. So I'm going to go to a video in a second, and in the video I'm going to show you 2 different ways to think about putting this group going away from you in space. So one way would be to just think about an axis through this carbon here, and then rotate around this axis until your lowest priority group is pointing away from you. Another way to think about it is like a Newman projection. If you stare down this bond, let me go ahead and change colors here. If you look down at this carbon-carbon bond here, so if you put your eye along this axis, so here's your eye, that would mean your lowest priority group, your ethyl group, would be going away from you. So that's another way to think about looking at the model, or the molecule I should say, in a way where the lowest priority group points away from you. So here's our compound. Let's say that red represents bromine, so there's bromine, and yellow represents chlorine. So our goal is to rotate this to put our lowest priority group going away from us. So if we think about an axis through our chiral center, we'll rotate it so the ethyl group is pointing away. And now we can see that our red bromine is to the left, our yellow chlorine is to the right, and the isopropyl group is up in space. If we go back to where we were, this time let's think about a Newman projection. So we're staring down this carbon-carbon bond. So let's rotate the molecule, and it's a little bit different perspective, but we're still able to see a red bromine to the left, a yellow chlorine to the right, and an isopropyl group up. So here's what we saw when we stared down our carbon-carbon bond. So this carbon is our chiral center, so that's this one right here. And then I used red for bromine, and then I used yellow for chlorine. So we can see that our bromine is to the left here, and this was the highest priority group. The chlorine is to the right, that was the second highest priority. And then we have our isopropyl group here up. So that's 1, 2, 3, with our lowest priority group pointing away from us. So all we have to do now is go around in a circle and see what we get. So we're going from 1 to 2 to 3 in a circle, so that means we're going this way around our circle. And that, of course, is counterclockwise. So counterclockwise is S. So the configuration of this chiral center is S.